It's just called factoring polynomials completely. So basically we have to watch for some shortcuts and make sure that we get everything factored out as much as we can. So, excuse me. So when we're doing stuff today, we go through that list of the check marks. So number 1 was factor out a greatest common factor. Number 2 was look for perfect squares. Number 3 was look to 2-step. Number 4 was look to 3-step. So we go through that procedure every time today, even after we factor at some levels, to make sure that we factored it all the way out. So again, to factor a polynomial with 4 terms, sometimes it's easier to factor by grouping and then look for each pair of terms GCF to factor something out and factor out a binomial factor. So here's what this means. If I look at letter A, I have x to the third, x to the second, and x. So I don't have any common term I can factor out of any of these numbers or variables. But if I group the first 2 together and I group the second 2 together, I should be able to factor something out of those pairs and have a common binomial. So if I look, what I can factor out of the first set is x squared. And what that leaves me with is x plus 3. And if I look at what comes out of the second one, I can factor a 2 out, and I'm left with x plus 3. Now, this should work out this way every time. They should have a shared binomial now that you can pull off of both of them. So I'm going to pull this factor of x plus 3 off of both of them. And what I'm left with is x squared plus 2. So remember that everything that's hooked by multiplication is actually one term. So this is all one term. This would be like, can I factor off 2x and let's say like 3x? Well, the x's can be factored off of each of those terms, and that's kind of what's going on here. I can factor off that binomial. So same thing on letter B. If I group together, I can factor out, well, let's see. Oh, I need to write that in standard form first. Let's do that. So when we do letter B, we have a degree of 2. This one has a degree of 2. And then typically we go alphabetically. So then it's x plus y. So now that's in standard form. So we have degree of 2, degree of 2, degree of 1, degree of 1, and we just went alphabetically. So if I factor now, I can factor an x off my first term. I'm left with x plus y. And now here's the weird thing. I want this to say the same thing, and it's technically already the same. So I'm just going to put plus 1, because I can distribute this 1 through, and it still means the same thing. So I'm going to put x plus 1. So the common factor that I get off of both of them is the x plus y. And what's left outside that is the x plus 1. Again, factoring by grouping is the new thing today, but again, we're just factoring 2 things at a time. So take a second, pause, try these. Like I said, it really helps to write these in standard form, so I'm going to help you guys out on 2. If I were to write this in standard form, it should be xy plus y squared plus 2x plus 2y. Okay, and I'll always help you guys out with those. Just make sure we get it in standard form, and you should be able to pull those off. Okay, so if we do number 1, I can factor an a squared off of both of those terms, and I'm left with a plus 3. It already says a plus 3 on the other side, so I'm going to put plus 1, and I have a plus 3. So now the shared factor, the shared binomial, is a plus 3. And what's left is a squared plus 1. Okay. This one, I can factor a y off. And I'm left with x plus y. And then I can factor a 2 off. and I'm left with x plus y. So the shared binomial is x plus y. And then I have y plus 2 is what's left. Oh, excuse me, sorry. All right, so now, once we're done factoring, we always look for perfect square pattern. So recall from last week, we had x squared minus 1 factors into the difference of perfect squares binomials, x plus 1, x minus 1. If you see something like this, however, x squared plus 1, it does not factor, so that's already factored out. So keep in mind there are some things that we might miss if we don't look for those patterns. So again, here's our list of 4 that we talked about the other day. So factor out a GCF. Look for the difference of perfect squares. Again, I always say look to 2-step first, then to 3-step, and then if we have to, factor by grouping. So they kind of lumped together 2 and 3-step here. So on example number 2A, first things first, I'm going to look, and I should hopefully recognize I have 3, 6, and 18. I can factor a number off those. Not only that, but I have x to the third, x squared, and x to the first power. So when I go to do this one, I can actually factor a 3x off of everything, and I'm left with x squared plus 2x, and then minus 6. Now, if I look at what's in the grouping symbols here, I can probably 2-step this. So I want the multiples of negative 6 that add up to, positive 2. So if I list my pairs out, it's 1 and 6, and then 2 and 3. So it looks like, let's see here, did I make a mistake? 3, 2, 6. I don't believe so. This cannot be factored any further. So sometimes it works out this way. This is actually factored all the way out. We can't factor this any further. Every now and then you'll have something where you can, but this is actually our answer. We cannot factor that out any further. I'm guessing it'll work out a little differently where we can factor out further on the next one. So let's see. Again, I have 7x to the fourth and 28x squared. I'm going to take out 7x squared. I'm left with x squared minus 4. And now we have the difference of perfect squares. And as we'll recall from last week, just factors into x plus 2, x minus 2. So again, it's the square root of the first term goes in front, square root of the second term goes in back, but it's the difference of squares pattern. So this is our answer right here. This is factored out completely. Okay, solve an equation by factoring completely. So this is where we want to find answers for x. The first thing we need to do is move everything to the same side. So I have 2x to the third plus 8x squared minus 10x equals 0. Now I want to factor out the GCF, which is 2x in this problem. So we have x squared plus 4x minus 5 equals 0. So now that we have this, we want the multiples of negative 5 that add up to positive 4. Now, if they want us to solve here, it's likely that it's going to work out and factor for us. So our only multiples of 5 are 1 and 5. One of them needs to be negative. We want the 5 to be positive and the 1 to be negative. So when we go to factor this out, it's 2x, x plus 5, and x minus 1. So now when I go to solve these, I just set each thing equal to 0. And I get my solution. So if I had a third power at the beginning, I should get 3 answers. Now, sometimes they might be repeated roots or repeated answers, but more often than not, you should get 3 answers. So x equals 0, x equals negative 5, and x equals 1. Okay, Okay, so again, try these. Again, pause the video, guys. Please try these, work them out. I'll work them out quickly here in just a second. Make sure you re-watch the video, re-listen to the explanation. It really will help you guys in the long run if you go over it a couple times. Make sure you get this all written down in your notes. So number 3, I'm going to factor a 3x out, and I'm left with x squared minus 4. And I can factor that x squared minus 4 because it's the difference of perfect squares. So it's x minus 2, x plus 2, or if you put plus first, that's fine. But that's your factored out all the way answer. Okay, number 4, we can factor a 2y out of everything. We're left with y squared minus 6y plus 9. We want the multiples of 9 that add up to 6. So 1 and 9, 3 and 3. And this is actually a perfect squares pattern. So 9 is a perfect square. And this actually factors into y minus 3 quantity squared. Now, if you two-stepped this, you should have got negative 3 twice anyway. Because negative 3 times negative 3 is 9. Negative 3 plus negative 3 is negative 6. But we can write it like this. It's a shortcut. Okay, next one, we can factor an m out. We're left with m squared minus 2m minus 8. Again, we want the multiples of 8 that add up to 2. So we have blank times blank equals negative 8. Blank plus blank equals negative 2. And we want negative 4 and positive 2. So we get m and then m minus 4 and then m plus 2. Okay, on the next ones we're solving, so we can factor out a w. We're left with w squared minus 8w plus 16. Again, this is a perfect square pattern. This is a perfect square. This is a perfect square. So this actually factors into w minus 4 quantity squared. So when we're getting our solutions, our only solutions are 0 and 4. And 4 is actually a repeated root or a repeated answer. Number 7, we can factor an x out. We're left with x squared minus 25. And that factors, that's the difference of perfect squares. So it's x plus 5, x minus 5. So when we find our solutions, we should get 0, negative 5, and 5. Okay, and then the last one, number 8, we can factor a c out. We're left with c squared minus 7c plus 12. We can two-step this, so multiples of 12 that add up to negative 7. And we have, let's see, 1 and 12, 2 and 6, 3 and 4. So we want negative 3 and negative 4. So we get c, c minus 3, and c minus 4 equals 0. So 0, 3, and 4 are our solutions. Now, again, we're going to practice this, you guys. It does take some time and practice to see the patterns, to make sure we factored everything out all the way. So don't stress out if we don't understand it right away, all the way. This is stuff that we haven't done before, technically. So factoring, again, like I said, that's the whole reason we broke the chapter up into 2. So make sure that we look to factor out completely, look for the difference of squares, look for GCFs, and they'll help you out, okay? Thanks, guys. Have a great day.